Welcome to Elixir Wizards, podcast brought to you by Smart Logic, a custom web and mobile development shop based in Baltimore. My name is Justice Epen, and I'll be your host today. I'm joined by my cool as a cucumber co-host, Sunday Mint, and my professional as a platypus producer, Eric Ostrich.
Hello.
Hello there.
Okay, really glad we're on to season 6. This is the premiere, the pilot. The first episode of season 6. We're very excited to be launching this. Today's guest is a luminary who needs no introduction, one of the inventors of Erlang, probably the best qualified person in the world to define the word beam, which is what we're talking about this season. Season 7 is all about beam magic. We're taking a look at what gets handled under the hood with Elixir and other languages that run on the beam, talking about how much magic is the right amount. There are a lot of strongly held opinions about this, so we're really looking forward to this season. It's going to be exciting, dramatic, hot. I can't wait for it. Basically, we want to dig into what is hidden by programming languages and talk about how people find varying levels of functionality and abstraction, whether it's useful, problematic, magical, and of course, the beam, the virtual machine. Great. So today we've got Robert Virding on the show. How are you?
Hi, I'm fine. By the way, what have you got against platypuses?
What did I say? He's a professional as a platypus. I said that I'm implying that platypuses are extremely professional.
Okay, yeah.
I just see platypuses like as akin to penguins, where they just seem like they're buttoned up, really put together. Platypuses are party in the front, party in the back. I guess I don't know.
I grew up in Australia. That's why I was wondering. Right? Okay, so that's what.
Oh, you're from Australia
originally? Well, I'm Swedish, but I grew up in Australia because my father was working there for a Swedish company.
Swedish by way of Australia. And where are you calling in from today?
Stockholm. So I live and work in Stockholm now.
Very nice, very nice. Well, I think we've had other folks on the show from Stockholm before. I cannot remember who it was, but we've definitely had stories about Stockholm.
I think Twitch stream, maybe?
Johanna was previously from Stockholm. I think she might be in London now, but maybe moved back. I don't know. So.
Oh, yeah, there are quite a few of us here in Stockholm, so yeah.
Well, Robert, we wanted to open this conversation by asking the question, what is the Erlang rationale?
The document as a whole was that I was thinking around 2000-something, 4 or 5, whatever. I realized that we'd never really said why we were doing things. So I talked to Joe about this as well, too, Joe Armstrong, and he's thought a bit and he said, no, we haven't, have we? So there was a book out, a couple of editions of people using it, products doing it and things like this for it, but there was no real description or saying why it looked like it does. And that's what I tried to put together in the rationale to say why is it like it is, right? Try and explain a bit anyway why it looks like it does, why it does some things and doesn't do some other things as well. That was the main goal for it.
And could you maybe take us through some of the highlights of the rationale?
Well, I mean, some things, why is a lot of concurrency there? Why do we have processes? Because that's the type of thing we were doing, right? We wanted things to be able to handle errors, which means, for example, processes should be isolated. Because if you have processes working together with things and one process crashes, it might ruin the data for another process, which you can't do. So they need to be isolated in some way. Things like this came up for it. And then we decided we'd have processes and we'd have data. And they wouldn't mix in some sense. They're two different sides of the same thing. And then we decided, well, we want to build fault-tolerant systems, and things are going to go wrong. Of course, they always do. You might just accept the fact things are going to go wrong. So how can you build systems that can handle errors, can detect and handle errors? So that's why that came in for it. And then there were a lot of other things that came along as well in the language, what we're discussing about. Some things we inherited from Prolog. The original system was written as an interpreter written in Prolog. We inherited things from that. Some of the syntax comes from there. The bits people complain about, the semicolons and the capital variables starting with capital letters, they come from Prolog. And the dot. And a lot of other things as well, too. Features that are in there. And it also described a few other things that was going on, how we ended up doing I/O, for example. This front end for it. If you run Erlang or run Elixir as well for that matter and press Control-G in the browser, it pops up into a little thing and it asks you to do a command if you try that. And then if you put a question mark, you can do various commands there. It's a little front end running multiple tasks at the same time in the same system and collecting remotes and things like that, remote shells and things like this as well too. Try to explain these things, what was going on in our heads while we're doing it. And as I said, I talked to Joe about it, and we realized that Joe, Mike, and me, Mike Williams, the third guy in the original group, we had thought so much about this that we thought all this was self-evident. Of course it looks like this. It could not look like anything else, right? And that's why we never wrote it down, or never wrote down the reasons for it, if I put it this way. The descriptions of it, of course, but never the reasons for it. And that's why the rationale came.
You've mentioned Joe Armstrong a few times. For our audience who maybe isn't as familiar with the origin story of Erlang, can you speak a little to who is Joe Armstrong and how that the three of you kind of got together?
Yeah, so Joe Armstrong, he was a colleague and a good friend of mine as well too. He died last year, unfortunately. So we had met at Ericsson. We were working for Ericsson at that time had a small computer science lab, and we were working there. Mike was one of the people who formed the lab. I came in a year or so later, and Joe came in a year after that. So we met through the computer science lab working there. And we were looking at, the computer science lab was looking at things like how we can introduce new technology into Ericsson and things like this for it. And amongst other things, how could we better program the switches they were doing? I mean, they had some very successful switches with no problems there, but they were quite complex to keep up. And how could we improve that? And that's what eventually became Erlang, amongst other things. So we met through the computer science lab.
We've heard, a lot of the legend of Joe Armstrong. Is there any, fun story that maybe hasn't come up yet in any talks yet that you want to share?
I don't know. We were always arguing. I mean, Joe, Mike, and I were always arguing about things, right? I mean, it wasn't a very nice, smooth path Erlang ended up coming through. A lot of arguments going on. Classically, we sat in 3 rooms beside each other, shouting at each other, right? But we arrived at a very good end. I mean, I can say there were positive arguments. There were arguments that were going somewhere, not just being negative.
Debates, as we call them.
We could call it debates, yes. We can call it debates, yes.
Discussing so you're saying issues, that you were all programmers.
Yeah, we were yeah. So we had a lot of fun that night. I remember Joe and I would often take long walks during lunch. So we were out in the Stockholm suburbs. We'd take long walks there and discuss things, both work and personal things and private stuff. We could have long walks for it. And I mean, a lot of things went backwards and forwards when we were discussing where we ended up. And sometimes things just end up where they happen to be, and otherwise we made choices. I mean, for anyone interested, there's a classic one, and that's if you you can have a process ID and you can send messages to it. What happens if the process has died? We had a long discussion. What should happen if you send a message to a process that died? Should it just disappear, or should you get some signal back saying the process has died, and discussions went backwards and forwards. And finally we end up saying, well, the message just thrown away. That's not, you have to keep track of processes. The system's not going to do that for you. But that was a discussion that went a long time backwards and forwards. There were other things like this as well too. Variable scoping. Do we have variable scoping or don't we have variable scoping, et cetera, et cetera. It was a very productive set of discussions, and we all were friends personally as well too. So the families were friends and things like this. I can just say one thing: his 2 children were born in the same years as my 2 eldest children. I don't know if there's anything deep in it, but yes. Well, yes.
I feel like there's a lot of questioning there. I mean, did they become friends? Or are they like cousins? Or
the families were friends. I mean, we lived in different parts of Stockholm, so it wasn't that close. It wasn't that physically close anyway. But we were friends. We met and things like this. Well, we still do. I mean, we still meet with Joe's wife and his children occasionally as well too.
So, Robert, I'm going to ask you to dig a little bit further back into your early career becoming a computer scientist. Can you talk a little bit about your training and maybe tell the narrative all the way up until the point of getting a job at Ericsson and putting yourself in that room with those 2 other guys?
I'm self-taught, basically everything. I think I did a 3-week course along the whole progress. That was much later, but otherwise it's self-taught. I originally started taking a PhD in physics, theoretical physics, in Stockholm. And they got their own computer. They weren't using the university's computer system. We're talking late 70s here. This is a long, long time ago. And seeing I was a PhD student, I had free access to that and a very helpful and friendly system administrator. And I discovered a program together with a few other colleagues as well, too, at the same time. And that's how I got into programming. So I bought a book on writing games in BASIC. And this was a VAX VMS, and they ran BASIC, so I implemented a few games. Yes, that was fun. I mean, you write the game, then you run it once and it's done. But then one of the games was too big, so I couldn't do it in BASIC on the system, so I had to do another language, of course, the last and best game, of course. So I taught myself Fortran, and a mixture of Fortran 77 and Fortran 4. It all was running on the machine. It was there, right? So I learned that. That was quite fun, actually. And then the physics department started getting knowledge of me that I was doing programming, and I was teaching myself Pascal at the same time. And I helped them convert a few programs from Fortran to Pascal for student use and things, student programs, things like this, and taking part in some student projects, writing assembler code, VAX assembler and Z80 assembler, doing things. Yes, that was a lot of fun as well too. But that was more or less self-taught. As I was saying, I was doing projects for the physics department as well. But then we both realized I wasn't going to become a physicist, so I might as well just. We sort of friendly. In a friendly way, I left. And one of my colleagues, he started working for Ericsson, and he said there was a job. There was a place I could look. I could try one position at Ericsson I could look at. So I looked at that, and that's when I started working for Ericsson. And that wasn't at the computer science lab. That was for a small team in Stockholm managing Ericsson's VAX VMS computers in the Stockholm area. That's what it was doing. And that left me time to do other things. So I started doing fun projects for me. Well, things I thought were fun. I ported Franz Lisp from Berkeley Unix to VMS. That I was probably the only user of it, but that was quite fun actually, because it also taught me operating systems, because the Franz Lisp system we used, it was very close and explicitly used the Unix system functions. So I had to rewrite those for VMS and stuff like that. And I think that's how the computer science lab got hold of me or found out about me, and then I went to them after a while.
I'm sorry, Franz Lisp isn't the composer?
Lisp. It's a Lisp dialect.
Okay.
I think you can still find it. It's still around somewhere.
I had to Google it, and then Google auto suggested to the correct thing, I think.
Yeah.
So there'll be a link to the Wikipedia.
It's Franz Lisp, and the compiler was called Lisp with the Z in there, right? So yes, so it's the whole thing for it. It was quite a fun system, but it taught me quite a lot about operating systems and interfacing. So I rewrote a lot of the Unix system functions, calling VMS system functions instead in a reasonable way. So it wasn't that good, but it was fun doing it.
Justice looks like he has like 5 questions.
I do have one in particular. It's very perpendicular to this line, which is that if you're studying theoretical physics, I think that a lot of people are, especially if you're not a sophisticated computer scientist, you might be wondering about physical simulation. You're at the intersection of these two things. So what can you tell us about, like, how far are we from simulating a universe on a...
We need a bit more power. We need a bit more power there. They were doing symbolic simulations at the physics department. That's why they got their new computer, because they wanted to run very large background jobs for it. I never really got into that. So I sort of I left physics before I got that far doing it. But that's why I was doing it. That's also why I started learning Lisp as well too, because that's what they were using.
Do you see it as a fruitful direction of inquiry?
Yeah, fine. I think you just need to work out how far you can get. I mean, to do a reasonable simulation. Right? I mean, if you start looking at the real world, there's a lot of stuff in there. I mean, even if you look in your brain, there's an awful lot of neurons running in your brain, right? And if you try and simulate that's not a trivial thing to do. You can do it, of course. You can look at it, and other things, in looking at physics as well too. You just have to understand what it is you're actually simulating, or what your simulation is showing. Right? I'll put it this way. I think that's a difficult part. I've never really gone into that afterwards, but a bit of AI, but that's about it. But yeah, so I'm self-taught.
Somehow I expect that your never having gone into the thing is still like an order of magnitude more understanding than the average.
I don't know. So, well, yeah. If you think something's fun and you've got time to put some effort into it, you do pick up quite a lot. You just have to realize what's going on there, right? And try and work out, just try and get a feel for what the subject actually is. If nothing else to see, trivial, am I interested or not? Until you look at things, you don't really know. Sometimes things sound very interesting, but you start looking at them and they're really boring. And sometimes you get things they sound extremely boring, but when you start looking into it, they're actually very interesting. You just have to get in a bit to find out what's going on and how to work with it. I was very lucky with that. Both I had time at the physics department, before I left, and also when I got to the computer science lab at Ericsson, they were looking at new technology. That was one of the things I was supposed to be doing, which means you had to go in and look at new stuff along the way, which was what I was doing privately anyway. So yeah, that was good.
Can we fast forward to when you first heard the word Erlang? Where were you? What was going on?
That was at the computer science lab in Ericsson. And we've been doing other things. So Erlang is the name of a Danish mathematician. Was the name of a Danish mathematician who did work on networking, network reliability and network capacity and things like this. He was a mathematician on that. So from that point of view, using the name Erlang in a telecoms company was very, very relevant. We actually used the name before the language. And the first time I remember we used it was we gave a talk at a logic programming conference in '86 in Salt Lake City. And there we presented a system running telecoms using concurrent logic, parallel logic, and that we called our system Erlang. So we got the name first, we just kept using it when we got into the Erlang language. So that somewhere around there, that's the first time I heard of Erlang when we started using it.
So it wasn't one of the three of you that proposed the name. It came from this project that you had.
I honestly can't remember. I honestly can't remember where we got the name from in that sense. Right? That's the first time I remember we actually using it. You can still find it in papers on it, but we probably came earlier anyway as well. Too. Some people say it stands for Ericsson language, but no, it wasn't. It was a mathematician. This was the 80s, right? You named your programming languages after dead mathematicians. Right? So
thank you for disabusing everyone in the audience of that false notion. So if we want to define another term, and this is really important because your definition will set the tone for the rest of this season.
Okay.
And so we want to know.
No.
It'd be hilarious if you just made something up entirely. That would be really funny. Don't do that, though. What is the beam?
Okay. The beam, it's a virtual machine to run Erlang. No, that's the simple answer. It says everything and says nothing. Right? It stands for Bogdan's Erlang Abstract Machine. That was actually the second virtual machine we did for Erlang. The first one was called the JAM, Joe's Abstract Machine. Literally, that was used, right? So he designed that, and Mike Williams, he implemented it in C. So Bogdan Hausmann, he was another guy working at the lab, and he was looking at making an improved, better virtual machine, a faster virtual machine, and that's what the beam was. Originally, it generated C code, which was then compiled and ran. That had to be dropped after a while, but that's what the beam stand, where the name comes from when it came around, sometime around 92, 93, I think, something like this. That's the first versions of the beam. Probably the only thing that left is still the same as the name. I mean, it's totally been rewritten. I don't know how many times internally, extremely improved an awful lot over the last 25, 30 years.
And for people who are self-taught like yourself, perhaps, in web development, and because the whole notion of the virtual machine, when you start using something like Elixir, is abstracted away from you. So what does it mean for it to be a virtual machine? What is happening that would be useful to the average developer?
So it's a virtual machine like any other processor. It has a set of instructions and a set of ways of handling data for it. And when you compile down your code, you compile down to those instructions, that machine instruction. It's a virtual machine, virtual in the sense that there's no real processor. There's no Erlang processor down there. There were actually attempts to make one, but never got around to it. Never got that far. So it's a virtual machine. So with a virtual set of instructions, handling of data and things like this for as well. And then, of course, you have to implement that machine in something. So that machine is implemented in C. It's a standard classic C, and that's how you run it. But when you compile your Erlang code, or Elixir code of that matter, as well, of course, you compile it down to the Beam virtual machine instructions, which are then implemented, which are then emulated and run in the machine. It's an extremely specific machine for running Erlang. By the way, most of the time I say Erlang here, everything I'll say will apply for Elixir as well. Because, for those who don't know, Elixir compiles down to Erlang, which then compiles down to.
I think that's a very important distinction to make up front, because a lot of our audiences are Elixir developers who maybe haven't dug too much into Erlang and understand the relationship between the two. So thank you for pointing that out.
Yeah. So that's nothing wrong. That's the right choice, to be honest. So the Beam runs Erlang. That's what it's designed to do. It's very specific for running Erlang. The connection between the Beam and Erlang is very tight. And Elixir, when that's compiled, is compiled down to Erlang code, which is then compiled down to Beam code. That's why a lot of things in Elixir look like they do, because it's running on top of Erlang. It can't do very much else. Not if you want to do it efficiently anyway.
I think we ran into this yesterday while prepping a script. I actually found out that there's two abstract formats possibly. So there's the Erlang abstract format, which I think Elixir is in, and then there's also something called core Erlang.
The Erlang abstract syntax, that's what Erlang parses down to. That's what Elixir generates. LFE generates that as well, for that matter. And that's then passed into the Erlang compiler to generate Beam code. Core Erlang it's more like an internal language in the compiler. You can write core yourself. You can generate core yourself. I've done it, and other people do it as well too, and then pass it into the back end of the compiler. It's mainly used as an internal language inside the compiler. Actually, it's a small proper functional language. You can actually write it yourself, and you can print it out and get the compiler to generate it for you and show what it looks like and things like this as well too. For it. It's just some things have been simplified. Well, made more standard functional. For example, it has variable scoping and things like this for as well.
You mentioned LFE. Do you want to define that and talk a little bit about it as well?
Okay. Yeah. LFE, that's Lisp flavored Erlang. I'm a Lisper. Okay. Once you love the parentheses, then it never goes away. So it was actually the first high level language I learned. It never got into being Erlang syntax, which is probably lucky. I thought it'd be fun to try and implement a Lisp on top of Erlang, in the sense that it would be a real Lisp, but it would be adapted to running on top of Erlang and the Beam, and in that sense could interact with everything else running there. There's no problem calling Erlang code or Elixir code or being called for any of the reason, having things written in both systems running, all three languages or more running at the same time. It just works. And that again was a design decision. That meant that it was a bit different from many Lisps. For example, there is no mutable data because Erlang does not have mutable data, and the Beam does not support mutable data. That's just the way it works, right? That's why you don't have mutable data in Elixir, because it's running on top of a system which doesn't support it.
And that was a conscious decision you all made as one of those arguments back and forth, or was that sort of a unanimous decision?
It sort of happened. I think it's probably, we were running, the first versions of Erlang were implemented, an interpreter written in Prolog, and Prolog has immutable data. They have logical variables which are sort of halfway in between, but otherwise it's immutable data. So that's what we ended up getting, and that's what we ended up having. If I put it this way, we kept that, and we found that was a perfectly good design decision we made. There was no reason to change it. It made things like keeping processes isolated much easier, because actually processes can share data, but because the data is immutable, no process can ruin anything for anything else. We kept that and thought that was quite a good choice. In many ways, it results in much cleaner code. For example, I know that if I pass data into a function, that function can never change that data. Nothing can change under my feet. None of my data can change under my feet because it's immutable. So if I pass data into a function and I want something, it's going to modify it. It has to return the updated value to me. And I can throw that away, or I can keep it, whatever, but I can't change things. That makes a lot of things much cleaner. It's easy to understand what's going on.
This is getting to the good stuff, because we've talked about on this podcast a number of times about how we feel that Elixir code renders to cleaner code writing. And we've never really been able to pinpoint all the way down to maybe the origin story of why that feels that way. And Now we're talking to the literal creator of the underlying foundation, and you say the same thing. So that's a really interesting point.
It is. I mean, it is easier to write understandable systems, I think, if things don't change under you. Right? If I can see exactly when things can change and when things can't change. So I think that's a very good idea for it. One of the things we had, I don't know if I mentioned the rationale, but one of the ideas we had from the very, very early on, we want to try and keep things simple and explicit, and not have things happening behind you. That's why, for example, the only way processes communicate is by sending messages to each other. There are no backdoors at all between processes. That's the only way they can do it. That's how they synchronize. That's how they pass data and things like this for as well too. Again, because it's extremely explicit. That's what we felt with having immutable data. That was a very beneficial. Okay, I do a lot of training, and I realize that's one of the problems new people coming to this environment have, is the fact that they're not used to having immutable data. And it does take a bit of getting around the first things.
While we're on that topic, especially as it pertains to Erlang, what are the biggest hurdles you see to people who are learning Erlang? And if maybe you can help us who are new to Erlang leap some of those hurdles.
Yeah. What I've seen is the functional side. That Erlang and Elixir, for that matter, of course, because it's on top of it, it is a functional language. It's in many ways, the sequential languages are typical functional languages. And most things you'll learn other functional languages is applied to Erlang and to Elixir as well. In many ways, a bit simpler, but therefore, and I think that getting used to that is a big step. Getting used to passing data into a function and getting value coming back for it, and not being very difficult to reference things outside which you haven't been given as arguments and stuff like that. Once you get used to it, it's self-evident. It's clear. I look at my function. What can it work with? Its arguments. Right? Anything else? No. Are there any global variables? No. Are there module data? No. It's just that. I think but once you're used to it, it's fine. The other thing is a concurrency. Thinking concurrently. I mean, you're sitting running your operating system and you have processes and you can run things. I can run a couple of browsers and stuff like this for us. I can do things concurrently, but not at the level you can do in the Erlang system on top of the beam. Just this very thing of splitting things up into small processes that are interacting with each other and communicating with each other. That, I think, is a very big step once you start thinking about it. Now, I mean, a lot of times in tools, things like that will hide it for you. I mean, if you run Phoenix, you might have 100,000 connections, and Phoenix is quite happily, using Cowboy and underlying layers, quite happily starts up a couple of processes per connection for you. You don't see that, but it's doing it for you, and that's fine until you have to really understand what's going on. But I think that's the next step. A big step is just think this is how you split your system up into lots of little processes interacting with each other. I mean, if you go back to the telecoms, people, when we're working there, the idea was when you make a call, you will have a few processes on running the A side and a few processes running the B side, talking with each other. This is just for a simple call. You just split things up like this. That takes some getting used to. And as I said, I mean, typically when you're using libraries or packages, they'll do that for you. Like Phoenix or Ecto, things like this.
Which brings us to the second half of our theme, which is magic.
Doing things for you.
What is magic in your view? And is it good? Is it bad? How do you evaluate it?
Magic is fine if you understand what is going on. So, I mean, for example, we're talking concurrency. I can run up one beam, one node, and I can literally run millions of processes on that. And in some way, that's magic. I mean, you pick an operating system where you can run millions of processes, you're not going to find one. That might be magic. Right? And that allows you to do a lot of very fun things. But at the same time, you have to understand what's going on so you can use it in the right way. That's what I'm saying. It's both. That's both the magic side of it and the non-magic side of it. And understand, okay, I can run all these processes, which is fantastic. I can have my system with 100,000 connections, TCP connections coming into my browser, which is great. But what restrictions does it give me, for example? For example, these connections by default can't talk to each other. I can make them talk to each other, but I explicitly have to realize this is going on and then use that feature for it. How can I share data? Well, I have to write something that shares data for me in some way. I just can't send a reference to another process and have it access the data. It can't do that. So I have a lot of these things that come in for it. You have to understand. If you understand what's going on, you can use it in the right way. Then you can better understand the packages you're using to do things for you. Why they're good at some things and they have limitations for doing other things as well. I mean, talking web browsers, I mean, you can use Phoenix to do that. We'll do a lot of all this stuff for you for setting up the system, for running multiple processes for each connection, et cetera, which is great, right? But you have to understand that sometimes you hit the stage that if you don't understand what's going on underneath, you're not going to really get strange behavior, right? Why can't I just create some data here and another process can access it for me? In a real system, C or Java or whatever, I can do that. Why can't I do it here? That takes a bit of getting used to.
So this has already been one of the most educational episodes I think we've done so far. I still have a number of questions. I think the most useful one will be, again, I think a lot of people getting into the Elixir land are from Ruby. They're people who are used to a different paradigm, object-oriented programming, and just a totally different ecosystem. And so I'm trying to give them an on-ramp to Elixir and Erlang. I'm wondering if you can maybe help by suggesting how a new developer in this ecosystem can get the best stylistic practices under their belt. Where do they look? What are the main things to keep in mind when you're writing Erlang and Elixir code?
I think one of the things that Jose has said about Elixir since the very beginning, right, it is not Ruby on Rails. It might have taken a bit of the syntax from there, but it is a different language for it. It is a different language, a different system. You can't just get used to and accept the fact that you cannot write your old Ruby code in Elixir and run it and hope it works. Right? Or hope it does the same thing. That's a big psychological step to do that for it. Get used to that and do it and understand that means. Again, this is very much my opinion here, but even if you're using packages, do things for you, which is fine, right? That's good. You do need some understanding of what's going on underneath it, maybe even just at a very simple level, so you can understand what's going on here. It is not the same thing. You have to have a slight understanding of what's going on, not in the sense that you can't use the packages or anything, but it's a little bit. If you come too top down, you don't understand what's going on underneath. And in many cases, you can get quite far doing that because the packages you're using will handle all that for you. But eventually you hit the stage where it doesn't work anymore. I want to do something else, and suddenly it's behaving, from my point of view, very strangely. And then I have to understand what's going on. That's something you need to do. You need to understand that you have this problem, put it this way, or issue, not before it becomes a problem.
When you mentioned Jose, it actually gave me a question. Where were you and what was your kind of impression when you first heard the announcement for Elixir, a new programming language built on top of Erlang? Just curious what your thoughts were at that time.
Okay, being an old Erlanger, my first question was why?
How could you possibly improve on this?
Why? Yeah, okay. Now you're talking to me who'd implement 2 extra languages, 3 extra languages on top of that already. So I think doing it for the fun of doing it is a perfectly valid reason. I know he wasn't doing it for that reason. But that was my question. Why? What was he trying to do? Why do this? Right? Why introduce this way for it? What different things will it give you to do that? And in many ways, you could see it diverged from the Erlang side quite a lot, on not just the language size, but the culture side, the community and things like this, how the community worked and what they expected things was very different from the Erlang community those days.
I'm actually curious what the community differences are now.
They're probably becoming less in some ways. I mean, a very simple example of difference. I mean, the mix tool came very early with Elixir. I don't know which version, but it's extremely early for it. And that was just something that people that came into that community expected there to be a build tool. Whereas in the Erlang side, it took 10, 15 years before we got a build tool. And it's just what you're expecting, the type of systems you're building, where people come from, and this type of thing as well too. That meant a lot. I think that was one reason for doing it. And if I remember rightly, he said he loved Erlang, but he wanted to fix the things he felt were missing. not just build tools, but in the language itself and stuff like this as well. And I think you can see a lot of difference in the community. For example, the number of packages you can find for doing things in Elixir. An enormous number of them, right? Compared to what you can find in Erlang, where they're much fewer. And I think that's partially cultural and a type of system that's being used in. And that affects what you expect to happen, right? What you expect to be there, or will be there, or won't be there, and how you feel if you can't find it. Classic one is, I don't know if this is true or not. This is one of these generalizations you hear, that people come into Elixir and they said, okay, if I can't pop up a browser window in 1 hour, I'm not interested.
That's a fair point.
Yeah.
I've heard that from a few.
Yeah. As I said, it's one thing, I don't know if it's true or not, but to do that, of course, you can't write an Elixir. Then you expect these packages to be available for you, so you just plug them together and run things like that. That's a completely different size for it. Whereas if you're working in a project that might take 5 years, a week or two, it doesn't really make much difference. Again, it's just different cultures, different expectations and stuff like this.
Interesting. So was there a moment that you actually got to use Elixir, that you were intrigued by it, or was it sort of like a why the entire time, that like you heard it and you're like, why change it?
Yeah, I've got an answer to the why, right? That was pretty clear once you start looking at it, how it's worked and things like this. That's pretty clear. It didn't help me for the type of systems I was doing. Okay, I'll put it this way. It didn't give me everything for it. And being an implementation person, of course, I look at the implementation and to see what's going on underneath it and think how things are done and stuff like this, how it gets around various issues. I mean, a simple one, for example, is that there are no user-defined data types. That's it, right? The Beam, the Erlang system, the Beam does not provide user-defined data types at all. They're just not there. So there are things like that about what the system provides, what users expect, what type of things they're going to do with it and stuff like this. That's just, from my point of view, I wasn't looking at things like that. And of course, as I said, being an implementer, you start looking at the language itself. Right? When I write a with, why can't I put the first thing on the line afterwards and indent it 2 lines? I know why. By the way. So I know the reason for it. I know the answer to this, but why can't I do that? I would want to do that. And there's a lot of other things like this. I know the reason for them. There are things like this when you start looking at the language from an implementer's point of view.
Kind of along those lines with that thought process, can you tell us about your side project, Erlog?
Well, that was an experiment to write a prologue in Erlang. Again, write a standard prologue in standard Erlang, and not do anything strange or anything like this, or write stuff in C and plug it into the machine. Just write standard Erlang for it. And that was an experiment doing that. It works quite well. It's not very fast, but it is an interpreter. So it doesn't compile down, but it does do a full subset of standard prologue, and it can handle the database in the right way and things like this as well too, which is not that trivial to do in Erlang, to be honest. So that was just more a fun project to do that. It's there, it works, but I haven't worked for a bit. The LFE was, I love Lisp. That's to get back to that. That's why. So it had to have a Lisp on it.
Amazing. Well, that passion generates a lot of productivity for others. So
yeah. It's, I don't know, wondering a bit about Lisp's a fun language. I mean, it's old. I mean, what's it? It's 50, 60 years old, something like this for it. But it's still a very powerful and simple language for it. You can do an awful lot of stuff in it. It just works, right? And as I say, I like implementing languages.
For fun, yeah. Speaking of fun things, this came up at CodeBeam during one of the Toucan Lounge chats that, it came up at your talk as well, but the Erlang movie, we heard that you had thoughts about it, and we wanted to know what your thoughts were about it.
The old one, the original, that, I can't remember exactly, but I think that came about because we were going to present Erlang at some trade show or something like this. And we just wanted something to show for it. So we made this movie, and Ericsson had a movie team that helped us do that. And yeah, it became quite funny. It wasn't meant to be funny. We were quite serious when we were making this, but about the message we were sending across. We were actually quite serious with that. And then it became very, very weird stuff, right? Note one thing, however, Joe and Mike just sit there talking. I'm the only one who actually does some coding and fixes the bugs.
Was that true? Was that true to real life?
Amazing.
It does have a slight Monty Python feel to it, but yes. Yeah, then when Garrett Smith came up with the sequel, that is fantastic. I really love that one. That is really good. That's really good done. I like that. I think it was a bit nervous originally how we would feel about this, but that was really fun. Or it is really fun as well too.
We like to give the guest the last word, but I want to ask one more question, which is about the future and what your aspirations are for the future of the community, for your work in the community.
Yeah, I think. Well, I'm still working for. I work for Erlang Solutions, okay, and I mainly do training and things around that. A bit of consulting as well too, and I enjoy that. I plan to keep on going. I of course hope the Erlang community will continue, and I'm talking Erlang community. I mean the whole community of all the languages running on top of the beam in this case. For that to work, they have to collaborate more. We have the Erlang Ecosystem Foundation, which is doing a lot of this work, and I think that's a very important thing to get these things together to make it easier to use them all on top of the Erlang system. Just make it easy to pick packages from other languages and use those as well too. Why can't I run Phoenix from Erlang? Well, I know I can, but things like this or Ecto or stuff like this and going the other way, I think that would be something which would be very useful and good to do that. So I think that's very important for the future to do that. And I think that will make each of the languages more powerful for it. A while back, that there was a tendency for them to split. I think that would have been worse for both of them. Again, this is getting out to some people about 5 years ago, talking with Elixir people, and they said, well, can't we just get rid of Erlang? Well, you can't, because then you've got rid of Elixir, of course. And I think that's getting this realization that they work together, that they can improve each other and make it for it. Having a powerful Elixir community running Elixir helps the Erlang community, which helps the Elixir community, et cetera, et cetera, et cetera. And I mean, I know there have been discussions, can't we, whoever we happens to be here, write our own virtual machine? And of course you can. It's just a bit of code to get the same level. Well, it's a few thousand, tens of thousands of lines of code, but it's just a bit of C, right? But I mean, you get that level of goodness in the system, in the beam, to get right your own. That is an awful lot of work. I think they're putting an awful lot of really smart stuff in there continually. I think one thing you note, if you look at it from the Erlang point of view, the Erlang language itself is very stable. It evolves, but very slowly. And if you don't understand what's going on, you can get the impression no work's been done. But there's an awful lot of work being done in the beam. Every new version of the beam has something fantastic in it over the last one. And especially, I can just put a plug in, version OTP 24 that's coming now, right? soon. That it's got some really good stuff in it. There's a JIT compiler built into the system now. There was the old hype, but now there's built in it. And that is really fantastic. I just have to say this. But it works the other way. So when you're running this, the compiler still generates beam code, beam assembler. Then when it's loaded into the system, it's converted to assembler code at the load time, which means when I'm compiling my system, I don't have to worry about who's going to run it because it runs on all of them, but the loader does it for it. And it's just so fantastic. I mean, there's a slight increase in code size, around 10%, which is very small. The efficiency is sort of 5 to 10 to 20 times faster for many things. It just goes wham, right? And again, that is something you as a user don't see. So I don't see it in my code. It's just there. Right? And there's a lot of things that happened over the years in the beam that there've been continual internal improvements that are just happening. If you don't look, you don't see them. And so there's a lot of work going on there as well too. I think that's really great. That I hope will continue. And that, of course, will benefit all the languages. Because, again, Elixir doesn't have to think about it, because it just generates a Erlang code, which just gets all this stuff for free. It's wonderful.
Wow, this has been such a great conversation. Sorry, go ahead.
There are a couple of good blogs describing that system now, about the ASM JIT, I think they call it. It's really great. It's very impressive, to be honest.
Actually, my last section here is to offer you the opportunity to make any final plugs or asks for the audience, anything that you want the listener to go do. Shameless self-promotion is encouraged, so feel free. Do you have anything else like that before we wrap up?
Well, of course, being an old Lisper, don't be scared of parentheses. I know this is very different from the Elixir side where you remove parentheses. I say put them all back again and put a couple more in for good points for it. It makes the syntax much easier. You not get used to it. I like that. I sincerely hope the Erlang system will keep going. I mean, the Erlang system, the ecosystem foundation, the whole lot here will keep going and keep working together to improve these things for us as well. That is for running Lua. So I was originally started as an experiment to implement a language on top of the Erlang system which did not have Erlang semantics. Explicitly was different with different memory management. It's got shared global mutable data. Everything the Erlang system doesn't have. It's got that. And a few other weird stuff as well too. So that was an implementation of that. And that was quite fun to do, but now it's actually seriously being used, which is slightly nerve-wracking. Again, that's there. If you want to run things in Lua and you want to be able to plug them efficiently and easily into the Erlang system, that's a way of doing it. And I can say it's being used, two places I know. One is in a bank, and they are a serious bank as well too. They're not just they're an old bank. It's the OTP Bank. And I'm not kidding you about the name. It's the OTP Bank. It's a Hungarian bank, one of the bigger ones in Eastern Europe, former Eastern Europe. They're using that internally for doing scripting, and it's by a company called Creative Assembly. They're a gaming company. Which war game? Total War. They're the whole Total War series. They're not using it in the game side itself, but they're using it to allow users to customize their environments in Lua, of course, to do that.
Lua seems to have become very popular among game developers in particular.
It is. It was for World of Warcraft as well, for customizing that. You would write things in Lua as well, too. It's just really, really spread there. It's quite a nice little language, to be honest. It's a nice little language. As I said, it's very different. It's not functional. Well, if you read what Lua is, it's basically everything. Pick something and Lua does it for you. What I find is impressive, they managed to keep the language small. They make new stuff, but they're resistant to making very big changes for it and keeping it small. And it's a very powerful language as well, too. It's just managed to pick a very nice little set of fundamental principles that they're very powerful. That's why I like it. I like Lua as well. Now I can't show it, but I got my spaceships written in Lua as well, too.
Your spaceships.
It's a very simple little demo. One of the things running Lua is that you're running this in Erlang, so you can start lots of little world systems. So it's running spaceships, and each spaceship's customized, is programmed in Lua, and it's an Erlang process. So you're running 2,000 Erlang spaceships, and each one's an Erlang process customized in Lua, and that works fine. You could run more if you want to as well too. The final push is that one benefit of running Lua in Lua inside Erlang is the integration is very tight. You could run an external Lua and talk with it, but of course then the integration is much more difficult to do.
Wow. Robert, I feel like we could do a 3 or 4 hour long podcast with you, and maybe one day.
Yeah, you have to turn me off.
Well, no, we'd love to have you back, and next time we will, I think, plan more time. It's conversations like this that humble me and remind me that we stand on the shoulders of giants, and that we wouldn't be able to do the work that we do without brilliant, brilliant people who have come before us and put in a ton of legwork. So thank you so much for everything that you've done.
Okay, thank you. That was a lot of fun. So yes.
Oh, it's great.
Hope to get the sound working properly now, and then it's fine.
That's it for this episode of Elixir Wizards. Thank you again to our guest, Robert Virding, for joining us today. Elixir Wizards is a Smart Logic production. Today's hosts include myself, Justice Epen, my co-host, Sunday Mint, and our producer is Eric Ostrich. Our executive producer is Rose Burt. We get production and promotion assistance from Michelle McFadden and Ashley Stotts. Here at Smart Logic, we build custom web and mobile software. We're always looking to take on new projects. We work in Elixir, Rails, React, Kubernetes, and React Native. If you need a piece of custom software, hit us up. Don't forget to like, subscribe, and leave a review. Follow at Smart Logic on Twitter for news and episode announcements. You can also join us on the Elixir Wizards Discord. Just head over to the podcast page to find the link. And don't forget to join us again next week for more Beam Magic.